Okay. All right, and I gave up on using my stylus with SmartNotes. I'm just gonna use my document camera. Okay, so let's go ahead and get started. Can everybody see this?
Yeah.
Okay, and it's hard for me to switch back and forth between, seeing the meeting, seeing you guys, and then seeing my screen. So if you have a question, just instead of raising your hand or something like that, just politely, interrupt me and say, hey, Ms. Richards, how did you get that? Okay, so what I want to look at, well, first off, let me get a piece of paper. I want to kind of review what yesterday was about, because it sounds like there is some confusion. So you were going from radical expressions to rational exponents. Okay, so a radical expression would be like the square root. Okay, all you're doing, you're putting that in exponent form. Okay, so square root, whenever you see the symbol, you know the root. Okay, that is your root. Okay, and then this is all raised to the 1 power. So to transfer this to a rational exponent, okay, again, your base is a 16, your power is a 1, your root is a 2. And I like the example that the video had where she talks about, how do you know what goes where? Well, you know that, in a tall building, somebody who's powerful, they probably live in the very top. So if you have power, you're at the top, kind of thing. And then roots are on the bottom, roots on the ground. That's how she kind of related those to how to arrange this. Okay, does that make sense? And I think you had, like, towards the end, you had a few questions, like you had to actually simplify them. So it says, let's go back. I want to look at it. I had it pulled up. No, I didn't. Okay, so let's just look at it. Mm-hmm. Like this question, you had to simplify this. It said 36 to the 3/2 power. Did anybody have issues with this question? Nobody?
I didn't do that. I forgot to.
Okay, so let's go over these. So these, when you're going from radical expressions to rational exponents, they can go either way. You can go from rational exponent back to radical expressions. This is starting out as a rational exponent. It's going to be easier to make this a radical expression. Okay? So remember, the root is on bottom, the power is on top. So the square root of 36, all raised to the 3rd power. What's the square root of 36? Just 6, right? So your final answer was 260. Is that 6 to the 3rd power? Okay, that was the basis from yesterday's lesson. Do you have any other questions about the stuff that was covered yesterday? Okay, so let's look at your notes for today. You're going to use most of these when you are going back and forth, basically simplifying more advanced expressions, more advanced exponents. Okay, so I want to dive straight into this. So I want to, I don't know why they didn't. The other one, let's do 3 to the 3 half power times 3. All raised to the 1/3. Okay. So if the bases are the same, the exponent. Okay. So that's technically 1. If your bases are the same, you're going to keep the base the same. And so this is product of powers. When you have that, what do you do with your exponents? When your base is the same and you're multiplying, what do you do with your exponents?
Add them.
Add them. Good. So we are going to add these. It's just going to be fraction form. So you're going to use this calculator for fractions. They are great. So this keeps the base the same. And then what is 3 halves plus 1? If you type that in the calculator, you should get 9 halves. Okay. And then that is all raised to the 1/3 power. And now this is just a power of a power. You're just multiplying those exponents. Okay, so when you do 9 halves times 3 halves, you get our base is 3. When you multiply these two fractions, you are going to get what? 9/3, 9/6, 9/6, and then that will reduce to give you 3/2. So your final answer there is 3 to the 3 halves power. Okay, that's one way to work with radical expressions. Okay. The other way, let's say we have this problem 5 squared over 5 to the 7 halves, and number 2, all raised to the negative 1/3 power. Okay. All right, so if the exponents are the same, first off, here in this, sorry, I was thinking ahead. What you're going to use here, you're going to use the quotient of powers. Okay, so if the bases are the same, you can subtract your exponents, you're dividing. Okay, so that's going to be 5 to the 2 minus 7 halves power, all raised to the negative 1/3. So when you do that in your calculator, what is 2 minus 7 halves? When you do this part right here. You should get negative 3 halves. We'll see that. Okay, so we're going to have 5 to the negative 3 halves, all raised to the negative 1/3. Now this is still power of a power. You multiply your exponents. They just happen to be fractions. When you multiply negative 3 halves times negative 1/3, you're going to get 1 half. Okay, so that's going to end up giving you 5 to the 1/2 power. And I know this seems like very foreign to you right now, but the more you practice it, the better you'll get. Okay, any questions on these two problems? Okay, I'm going to move on. The next ones are not on this paper. Okay, so I'm going to use a piece of notebook paper. I'm going to go over a few more like that where it's in the rational exponent. we're going to have 16 over 16 to the 1/3 over 2 to the 1/3 all squared. Again, I am recording this, so you can always go back and watch this recording. Okay, so when your exponents are the same, what you can do is you can go ahead and do the math. You can do 16 divided by 2. What is 16 divided by 2? Well, that's going to give you 8. Okay, so this is going to be 8 to the 1/3 all squared. And if you recall what you did yesterday, going from radical expression to rational exponent, how would you put this? What would this be as a radical expression? Roots on the bottom, powers on the top. This is going to be the cubed root of 8 to the first power, right? And then all of that is raised to the second power. What is the cube root of 8? What times itself 3 times gives you 8? What times what gives you 8? Anybody?
2.
2. So this is going to be 2. And that's just going to be 2 squared, which is simply 4. I want to do another example kind of like this. Let's do 4 to the 3/4. That's not a 3/4. Times 5 to the 3/4. All raised to the third power. Again, your exponents are the same, so you can go ahead and do the math. What is 4 times 5? 20. And then that exponent's going to stay the same. 3/4, all raised to the third power. Now you're just going to use power to a power, multiply those together. So 3/4 times 3 is going to give you, the 3 times 3 is 9. That's going to be 9 over 4. So this is 20 to the 9/4 power. Okay. All right, so I think the rest should be all notes. So let's work from the other direction. Let's start with a radical expression and then go to a rational exponent. So let's simplify this. Okay, so there are 2 different ways you can do this. No, there's just one on this one. All right, so what I would like to do is, this is in radical form. I want to move it to rational exponent form. This is your root. Okay, and everything is raised to the 1 power. So that means you're going to have 8y to the 6, and then z to the 12, all raised to the 1/3 power. Remember, 1 is your power, 3 is your root. Okay. Now, that 1/3 will go with all of these bases. It's going to go with the 8, it's going to go with the y, and it's going to go with the z. So we are going to have 8 to the 1/3 power, y, and then what is 6 times 1/3? We're going to keep it as 6/3 for now. We'll reduce. And then 12 times 1/3, so it's going to be z 12 over 3. 12 times 1 is 12, all over 3. So let's kind of reduce that. What is that 8 to the 1/3? You can rewrite that as the cube root of 8 to the first power, which is just 2. Okay? I keep going. So that is 2. Y to the 6/3. What if you reduce 6/3? What's divided by 3. That's 2. And then on the bottom, we have 12 divided by 3, which is just 4, the z to the 4. So that reduces, that simplifies to 2y squared all over z to the 4. Questions so far? Okay. Do another one. Now we have 8p to the 6th power, q to the 3rd power, all raised to the 2/3 power. So this 2/3 is going to go with all of those bases. It's going to go with the 8, it's going to go with the p, it's going to go with the q. So we're going to have 8 to the 2/3. We're going to have p to the 6th raised to the 2/3 power. And then q to the 3rd also raised to the 2/3 power. Okay. Now I want to rewrite this 8 to the 2/3 in radical form. Okay, so 3 is going to be your root. So the cubed root, 8 is your base, and that's all squared. Oh, I have someone else joining us. Hold on just a moment. Nolan, I guess you left and you're coming back, Nolan?
Pressed Alt F4 on accident. That's my bad.
Gotcha. Guys, if you have questions as I'm going through this, just politely interrupt me and say, hey, where'd you get that? How'd you get that? Okay. So we are on example 2 here. 8 to the 2/3 in radical form. 3 is your root, 2 is your power. So that is the cubed root of 8 squared. Now p to the 6th raised to the 2/3 power, you're going to multiply it. 6 times 2 is 12. So that's going to be 12 over 3. We can reduce that later. And then here we're going to multiply those. 3 times 2 is 6. So that's 6 over 3. Okay. So what is the cube root of 8? You should know this one out. You should know that it is 2. So we're going to have 2 squared. 12 divided by 3 is 4. This is going to be p to the 4th. Q to the 6th third. 6 divided by 3 is 2. So that's 2 squared. 2 squared is 4. So this gives you 4 p to the 4th power q squared. Okay. I want to do 2 more examples. I know you're tired of meetings and this is overwhelming, but this is just something that I need to teach you and go over. Okay, example 3. Okay, this is what I was thinking. We've got 2 different ways we can do this. Okay. The first way I'm going to look at it in exponent form. I'm going to make everything an exponent. So whenever you have the square root of something, so let's say the square root of 4, that's really 4 to the 1/2 power. Okay, so these square roots are really great. That's really 2x to the 1/2 power. This is really 8x to the 7th, all raised to the 1/2 power. Okay, so if we do that, I'm going to keep this 3x kind of separate. We're going to worry about it later. But if we convert this radical to a fractional exponent, this is really 2x to the 1/2 power. And then if you convert this to an exponent, this is really 8x to the 7th, all raised to the 1/2 power. All right. Now we have something that we went over at the beginning. We have the same exponents. So when you have the same exponents, you can just do the math here. And remember, this is technically a 1. Right? So what is, we're going to worry about the 3x later. Keep it to the side. What is 2 times 8?
16.
Thank you. And then x to the first power times x to the 7th power. We're going to add those. We're going to do 1 plus 7. That's going to give you 8. And then all of this is raised to the 1/2 power. Okay, so the 1/2 goes with the 16. The 1/2 goes with the 8 to the x to the 8th power. So let's do that. Keep the 3x to the side. So if we raise 16 to the 1/2 power, that's really like the square root of 16, right? I'm going to write that separately. 16 to the 1/2. And then we have 8 x to the 8th already. So 16 to the 1/2 power is really the square root of 16. You'll see that it's a little small. And then we multiply our exponents here. 8 times 1/2. That's really 8/2. What's 8 divided by 2? That should give you 4. So this is really x to the 4. What's the square root of 16? 4. And then x to the 4th. Now we can multiply that. So 3 times 4 is 12. And then x to the first power times x to the 4th power is x to the 5th power. Okay. Now, some of you, I bet if you tried this before I started, were thinking you could multiply with any radical. You can. You learned that in Algebra 1. That is the other method I want to look at. So if you keep it like that, if we keep it in radical form, the 3x stays on the outside. 2x times 8x to the 7th, so 8 times 2 is 16. X times x to the 7th is x to the 8th. Okay. And then you know the square root of 16 is 4. But then when you get to this x to the 8th, it's kind of confusing, but it translates as x to the 8/2 power. And then you get the same answer, 12 x to the 5th. Okay. So if you think of it this way, great, you can do that. If you think of it in exponent form, great. Either way will work. Okay, so let's go over one last example. And this one's dealing with negatives. Yuck. All right, so the first thing I want to do is I want to get rid of that negative. So with negative exponents, you're going to take the same thing, whatever it is, and put it on the other side of the fraction. Okay, so what I'm going to do, this is going to turn into 1/49 y squared, all raised to 1/2. Okay. And then this is going to stay the same. Okay, so this is going to be the cube root of 27 y to the 6th. All right, so let's just break it down. Looking at the bottom of this fraction, sorry, that 1/2 power goes with a 49 and it goes with y. So you're going to have 1/49 to the 1/2 power. Whenever you see 1/2 power, you should be thinking square root because that's what it is. Okay? So what is the square root of 49?
7.
7, good. So, and then you're going to take that y squared and multiply 2 times 1/2. 2 times 1/2 is really 1/2, which is just 1, so that's really y, or y to the first power. All right, and the next part, all right, so I'm going to break this up as the cubed root of 27 times the cubed root of y to the 6th power. Because you know the cubed root of 27 is what? What times itself 3 times gives you 27?
3.
3. Good. So that's going to be 3. And then when you do this is going to translate as y. If you put this in rational exponent form, 6 to the power 3 is your root. That's the 6/3 power. Okay, and then what is 7y times 3? And then what's 6 divided by 3? 2. Okay, so now we're going to multiply this. I'm going to keep going up here. Oh, guys, you can't. Anytime I get off track, I can't really see my screen. Just tell me, hey, Miss Richards, we can't see what you're doing. All right, anyway, we're going to multiply straight across on the top. So 3 times y squared, 1 times 3 times y squared is just 3y squared. On the top, on the bottom, you still have that 7y. There's a lot of different ways you can do this. You can do 2 minus 1, or you can do 3. Y squared is really 3 times y times y. 7y is really 7 times. And then 2 of those will cancel out. So on the top you have 3y, on the bottom you have 7. Okay? I want you guys to work on one problem for me, and then I'll let you go. Let's do the let's do number 4 on your exponent sheet. So that is going to be number 4 says you have the cubed root of 4x squared y. I didn't mean to make that root so long. Times the cubed root of 2y. Okay, work on that problem really quickly and then I'm going to stop the recording.